It's kind of like your water maker that you would use. So one of those would be enough water for one person. The micro is really interesting, but the macro is really important here, as you can see. The shipping container is an ideal situation because it's so versatile, right? A lot of our slides, you'll see the shipping container used because that's what all of our consultants are using as a benchmark. You can ship it, send it somewhere. This system has a bottling facility in it. So if there's a disaster zone, you send a shipping container and it's creating enough water for that area in a time of disaster where they're rebuilding. Yeah, and H2O Futures, we'll talk about that, and then I'll let Ned speak about his experience. So mixed water works. You're able to mix seawater, freshwater. You have the freshwater works. So freshwater systems, efficiencies that can be found with more intense design or respect for the uses. And then the environment is really important. Untreated seawater, it's 3/4 of the earth, right? Are we really in a drought, or are we just not thinking about the right resources? So let's go to the next slide, please. And then you have high seed content if you're using the Salicornia and ornamental halophytes that can be produced with seawater. You can distill it, you can make makeup products, and you can make biofuel out of it, which is really interesting. And it's edible, right? And then you have the economy, so the sustainable developments, ecotourism, and you're graining arid climates, which creates a microclimate. So please, if you don't mind then, would you like to say a little bit more about your systems?
I'd rather wait. Why don't you go through
the whole thing?
And then we can focus on that. Yeah.
Perfect. Okay.
If you don't mind, that'd be great.
Sorry, I didn't give them any heads up about what we were going to do here today. So the next one, the desalinization, Septon Water Tech, I mentioned that they plug in to a geothermal resource to create freshwater resources. Their energy, they're trying to do that cogeneration. They have solar ponds that are really interesting too. Go to the next one. Freight farms, again, the shipping container comes about. They can produce, I think, yeah, you have 150 pounds of food per week at 7,200 pounds per year. And the rate of return, your margins on a pound of food are like $3 a pound. So this system itself, coming back to the economy, it could pay for itself in a matter of 4 or 5 years. Back to our experience with real estate development, there's always an ROI. If somebody wants to invest with you, they want to know how long it's going to take to pay off. Next. Water resources, the macro level. So you can see these pictures of the Salton Sea. These are algal blooms that happen that create a dead zone. And in that area, do you want to turn around? I'll jump over here. These create dead zones, and this is a prevalent system that's happening off the coast of Louisiana. They have about 1,000 miles of dead zone. If anybody's been following the news, Lake Erie is in the process of being hit with another algal bloom that last year cut off water resources to 400,000 people. This year it might be worse. And those conditions occur when you have all of this agricultural production pumping in the nutrients that get carried off with the water systems. So our effective measures are to use systems to treat those nutrients. So you have here, which is a really beautiful kind of image of a floating island system, and this is Floating Islands West. They have multiple different branches. These can treat about 10,000 gallons per minute of nutrient polluted water. So this is a power horse here, where you can install these at all of the river inlets that are coming into the Salton Sea. You can also do them in artificial wetlands, so you're processing the nutrients before it enters the Salton Sea. But I can imagine, and I've done calculations about how much it would cost to treat the nutrients in it. And it's a staggering number to treat it in 1 year, but if you start to break it up and use different systems, these floating islands treat a lot of nutrients and create a habitat. Next. Selenium extraction, you have intrinsic. These are the NASA scientist group that have been working with them for almost 20 years. And they're cultivating and partnering with floating islands to use systems such as these that are plants specifically interested, or they feed off of selenium, right? So if there's a selenium depletion, the plant starts dying. So it's really interesting to use biomimicry to pull heavy metals and things out of water bodies. Algae cultivation, they have the water, treats a lot of the water, environment, it cleans up the environment, creates biofuel, is really here in the economy. Biofuel, food, it's pharmaceuticals, neuroceuticals. Basically, algae can be used in a variety of different things. Animal feed, organic fertilizer is probably the most important for this area. Gulf clear water systems are the black water treatment, so we can kind of just go through that. The water treatment, millions of gallons, really exciting. Could be used here. Next. So this is a really interesting conversation because we're jumping to our power or our energy section. And this is really important because this diagram shows how you can integrate 3 different resources to create 3 alternative energies into a section, right? This section has a certain cost. There's 4 of these sections shown here. But you can easily quantify the data of how much it costs to build one of those systems, how much energy it produces, how much it actually shades and prevents evaporation in that agricultural drainage system. And if you combine that with floating islands, biomimicry, water filtration, you're also treating the water in a small section. So this thing can get multiplied however many miles you'd like to replicate the system. Floating systems are really interesting for evaporation of the water and also cooling the panels. You get about twice as much efficiency out of a solar panel when it's in proximity to water because it cools down the panel that is losing heat. So we look at the energy generation. Again, these are really interesting when coupled together, right? You're already building a framework. Now you're just installing what you have here, which is a barrel generator. And these could be used in any water body, as well as underground current water generators. You could have one right underneath the water surface that's also creating energy. Next. This is the saltwater power, which is basically the pressure retarded osmosis, which is creating pressure from the differential and the filtration through a medium. Next. Biomass, really interesting, back to a shipping container. They use wood chips, they use acorns, corn husks, almonds, almond shells to create energy. And interestingly enough, this was a conversation that I had with Sai, that these systems have an output of carbon monoxide, right? So we're really interested in seeing if algae cultivation systems can be plugged into that, where then you can process that and get the added benefit of algae cultivation as a byproduct, right? It's going to make this system more environmentally sensitive, and it's going to get a second benefit. So we're in consultation with that company as well, the All Powers Lab. This is just a quick one. Anaerobic digestion could happen if we're doing our own farming systems. This is actually, when I saw these images, I was just really excited because this is the key to alternative energy. Everybody's probably seen Tesla batteries coming on the market soon. If you can crack the shell, and I think this does a pretty good job of it, that these units can be recycled, they can be thrown in the trash, they can be reused, repurposed again for another battery. That's the most exciting prospect of this. It's not a battery, a lithium-ion battery. It's really bad for the environment to generate, create, and then when you have to dispose of it or recycle it, it's really labor intensive. So these systems can be magnified in series up to a large scale. So we have the environment degradation. This is a micro and a macro issue. You have opportunities for composting, which is really important. You have opportunities for food waste. A lot of our food goes in the trash. It could be reused with anaerobic digestion and decomposition to be able to reuse that resource as opposed to a loss. Most exciting of all is the huge fan. Now, this is really exciting because these can be scalable. Again, it could be one is a shipping container. You build the framework for it, and you can stack it up. So at one unit, you have an efficiency, you have a product, and that is concentrated carbon, which is really important for algae cultivation and other uses, energy resources. Next, algae for bioremediation. That's the Blue Nomad Foundation. That's Cameron Clark that does the wet lab. That's his nonprofit group that we're partnering with and hopefully working towards grants in the future. Cameron is a very accomplished scientist, PhD. He's a really smart guy, and he's in charge of the Makers Movement, which is really getting everybody together to be able to test these high-level scientific studies. right? Being able to test DNA extraction, right? Like these are concepts that have been reserved for really expensive schools and really overpriced laboratories. So bringing that down and having that accessible is really important. This is Carrie's group, the Save Our Sea and Eco Media Compass, where they've been sourcing and really bringing a lot of energy to remediation of the sea, having educational seminars, and we really hope that in the future we can partner on educational seminars here and at the sea. And the education component is really important. So we have environmental and carbon pollution. Everybody knows that this is a situation that is steadily increasing. We did have some good news yesterday with the clean power plan that the EPA just enacted, which is really important. It is a tip of the iceberg though, right? It's going for short measures, right? It's going for reductions of 30% in 15, 20 years. We could, with the carbon engineering group, sequester large amounts of carbons on an industrial scale if there's a benefit, if there's an ROI. If you can make money off carbon capture and reuse, then we could be, carbon neutral in 20 years, as opposed to pushing out this deadline where we need to start reversing systems. So the economy, let's just go quick through these ones real quick. Freshwater, ecotourism, agriculture, aquaculture. Go ahead. Income generators, all those products that we've mentioned. Okay. So talking about a pilot project, we're really excited. We partnered with the Kimley Horn Foundation. Alex worked on the grant with us. We're asking for a small little amount to be able to activate our land lease with the tribe. With $5,000, we can get 40 acres.